Okay, so today, 3, 6, 19, all right? So what we're going to do today is we're going to find the vertex of a parabola in standard form, okay? Standard form, okay? So if we had y equals some ax squared plus bx plus c, when it's already in this form right here, it's not as easy to get the vertex because it's not in that nice little parentheses, right? Parentheses squared is great, I love it. But the problem is that sometimes they come like this, right? We've seen them, most of the time we've seen like this because we can factor it, we can do things with it, but getting the vertex a little bit harder. So there's a little formula. Okay, first of all, the line of symmetry. We know the line of symmetry goes through, it has to go through the vertex, right? You guys agree with that? And let's draw a little picture. So let's draw a little picture on the side. Okay, so if I draw a little picture of a parabola, it doesn't have to be perfect, but let's draw a little picture. Okay, so if I were to draw a parabola, I know my line of symmetry goes right through the vertex. Everybody agree with that? Okay, it has to go right through the vertex. So if that's the case, it's also going to be the x value of the vertex, okay? The line of symmetry goes through the vertex, right? Right there, boom. So we know that whatever this value is, it's the x value of vertex. So we know that if we get our vertex, some x, y value, that whatever this x value is the line of symmetry, okay? So how do we find it? We're going to use this little mini equation. X is equal to negative b over 2a. Write that down, highlight it, box it, whatever you got to do, but this is the, for today, tomorrow, and this week, this is our formula. This is our formula. This is the formula we're going to use over and over and over again. It's our important, but it's an easy formula, but it is really the one we're going to use all week long, okay? So it's just negative b over 2a. Now, what is a and b? It's these numbers. And of course, we're going to do a problem, but whatever a is, so example, if I take a look at example 1, in example 1, a is the 2. What is b? B is the 16. You guys see that? And the negative 5 is my c. So when we do this form, we would put the 2 in for the a and the 16 for the b. This 2 is always here. It's part of the formula. Does that make sense? This 2 is always here. It's part of my formula. Okay? All right, now, the vertex, the parabola, is that negative b over 2a. It has to be because we know that the line of symmetry goes right through it. Now the vertex is a point, okay? So we can get some number here, and then to get the y value, we're just going to plug this in to our equation to get the corresponding y value, okay? So you use the negative b over 2a to get the x value. Whatever that x value is, you plug in to get us y. I'll say it again. Use your negative b over 2a to get your x value of vertex. Whatever that answer is, you take that answer and you plug it in for x and you get the y value, okay? Now let's do a couple of those. Let me show you how it works, okay? So example 1, find the line of symmetry and the vertex of this parabola. Now we're not even going to graph it, we're just going to find the vertex and the line of symmetry. So first of all, line of symmetry. Okay? So my notes tell me that if I want to find the line of symmetry, I'm just going to use that equation right there. All right, that's an easy equation. I'm going to, okay, x is equal to negative b over 2a. So it's equal to a negative 16. b is 16 all over 2 times a, and a is 2. So here's my value of b. I go negative b is 16 over 2 times a, and a is 2, okay? So then from there, we're going to simplify that into a negative 16 over 4, which is negative 4. So my line of symmetry, okay? My line of symmetry is a line that goes through the graph. So my line of symmetry is x equals negative 4. Circle it, okay? That's my line of symmetry. Easy. It's a vertical line. that's going to go through my vertex, right, at negative 4. Okay, that's easy. Now, the vertex, well, that's not very hard either. I know the vertex has to go through negative 4, right? So my vertex is negative 4 something. Okay, negative 4 something. Jacob's way ahead of me, so let's take our negative 4 and we're going to plug it in. We're going to plug it in for x. So I'm going to take it and take my y equals 2x squared plus 16x minus 5, and I'll rewrite this as y is equal to 2 times a negative 4 squared plus a 16 times a negative 4 minus 5. Now, me personally, you know, I make mistakes. Yeah, of course I do. I make mistakes all the time. So, easiest way to plug it in is just let the calculator do the work. Does that make sense? Let the calculator do the work. I mean, I could go 16 times 2 plus 16 times negative 4, blah, 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 blah. I might make a mistake, right? I might accidentally go and multiply that, make that a negative 8 first. That'd be a big mistake, but let the calculator do the work. So Brett's already doing it, so you just go straight to, just let the calculator do the work. So I'm going to go 2 parentheses, negative 4 squared, right, plus 16 times my negative 4, subtract 5. And what do I get? Negative 37. So my vertex is at negative 4, negative 37. That's my answer. Okay, so it's really a pretty easy little formula, okay? Negative b over 2a, get your x value, plug it in to get your y value. Say it again. Use negative b over 2a to get your x value, plug it in. I'll say it again. Use your negative b over 2a to get your x value. Once you get your x value, plug it in to get your y value, okay? Let's do another. Okay, example 2. Same thing, right? So first, line of symmetry. X equals negative b over 2a, right? That's my formula. That's my formula, negative b over 2a. So a is 3, b is a negative 8. A is 3, b is a negative 8. So I'm going to have a negative 8. I got a double negative. I can handle that. Over 2 times 3. Okay, 2a. Here's my 2, and my a is 3. Okay, so then I get an 8 over 6. I get 8 over 6, which reduces to, oh, is that 4/3? Yeah, I think that's 4/3. Or 1.3 repeating. Okay, so I get 4/3. Okay, so my line of symmetry is x equals 1 1/3 something. Okay, 1 1/3 something. So to get this something, plug it in. Plug it in. Let the calculator do the work for you. So I'm going to go, okay, y equals 3 times 4/3 squared minus 8 times 4/3 minus 10. I'm just going to use my calculator to plug it in, right? Fractions don't scare me. I got a calculator, okay? Fractions don't scare me at all. I have a calculator, right? So, plug it in. I'm going to go ahead and just go through this, and I'm going to go clear. I'm going to go 3 parentheses 4 divided by 3 squared. See, there's my 4/3. See how I did that? There's my 4/3. Subtract 8, 4 divided by 3. There's my 4/3, right? And then subtract 10, and I get an answer of negative 15.33333, which is 1/3, right? So it really is a negative 15 and 1/3, okay? Okay, so there's my vertex. Whoops, I should have done, there's my vertex. My line of symmetry was x equals 1 1/3. Okay, there we go. How am I doing? Thumbs up? So don't let the fractions bother you. Just use a calculator, okay? All right, ready to turn the page? Okay, you ready? Okay, turn the page. All right. Now, example 3. So it says, find the vertex. Is this a minimum or a maximum? Now, I can answer this question before I do any work. I already know. It's got to be a maximum.
It's got to be max.
You guys are totally right. How do I know that?
Because it's a negative.
Okay, everybody agree with that? Everybody agree it's a negative 2x squared, so it's got to be an upside down parabola. Totally right. So right off the bat, yes, it's a maximum. It's got to be a maximum. Okay, it's not a minimum. Good. And let's find it now. Okay. So again, our formula is x equals negative b over 2a. Really easy little formula, right? My a is negative 2 and my b is 5, right? So I'm going to go at negative 5 over a 2 times a negative 2. Negative b over 2a, which is positive 5 over 4. I canceled the negatives. Okay, so okay with that? Positive 5 over 4, or 1 1/4. So my vertex is going to be at 1 1/4 something, right? So plug it in. All right, I'm going to go, okay, y equals negative 2 times 5/4 squared plus 5 times 5/4 plus 7. Again, fractions don't scare me at all. I'm not intimidated because I've got a calculator, right? So let the calculator do the work. I'm plugging in my 5/4. I'm going to go negative 2, parentheses 5 divided by 4. There's my 5/4 squared plus 5 times my 5 divided by 4 plus 7, right? Let's see what I get for an answer. I get 10.125, which is 10 1/8. And you don't have to put them in. If you like the decimals, I'm okay with that. You don't have to make them fractions, but I do know that is 10 1/8. So my vertex is at 10 1/8. Good job, Derek. And I know it's got to be a maximum. Even though we're not going to graph it, it's going to look something like this. We're not going to graph it, but we do know it's going to look something like this because it's upside down. So that's got to be a maximum value. Pretty easy, right? You guys agree with that? Okay, last but not least. Now, so if we're going to graph this, if we find the line of symmetry and the vertex and the y-intercept, okay? Now the y-intercept is actually really easy. Can we get the easy stuff first? You okay with the y-intercept? What? So if we let x equal 0, if x is 0, we'll find a y-intercept. Well, that's pretty easy. I'm going to have y equals 2 times 0 squared minus 8 times 0 minus 5. But I bet you already knew it was negative 5. You agree? You probably knew it. But that's why it's negative 5, because if the x is 0, obviously you get negative 5. Okay? So my y-intercept is at 0, negative 5. Okay, I'm going to circle that. I'm going to come back to it, okay? Because when I graph it, I'm going to come back and use it, okay? Now, the next thing is to find the vertex. Well, I've got my new formula, my little, I like to call it a mini formula because it's really a little formula. So to get my vertex, let's use our x equals negative b over 2a, because that'll get my line of symmetry, right? So I'll go x equals, let's see, a is 2 and b is negative 8, right? So I'm going to go a negative 8 over 2 times 2, okay? Negative b, but b is negative, so I get a double negative. So I'm going to get a positive 8 over 4, which is 2. Okay, so here's what I know. We have a line of symmetry. X equals 2. Okay, a line of symmetry. Okay, I'm going to circle that and come back to that, okay? I'm going to use that. That's information I'm going to use later, okay? Now, to find the vertex, let's plug it in, right? So the vertex is going to be 2 something, right? But we're going to plug it in. Okay, we're going to plug in the 2. We're going to go y equals. Plug it into the original equation, right? So I'm going to plug it into this one here. Y is equal to 2 times a 2 squared minus an 8 times a 2 minus 5. And again, I'm going to let the calculator do the work for me. I'm not going to hassle with trying to do this on my own. So I'm going to go 2, parentheses 2 squared, subtract 8 times 2, subtract 5, and I get negative 13. Okay, now I'm ready to graph it, okay? I really am. So, knowing what I know, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ooh, knowing what I know, I'm going to put the x-axis way up here. How's that? Does that make sense? Put it way up there just because I got to go all the way down to negative 13. Okay, now line of symmetry is right here at x equals 2. I have a y-intercept at 0, negative 5. 1, 2, 3, 4, 5. Okay. And I have a vertex at 2, negative 13. Now I need at least 3 points. 2 points is good. I need at least 3 points to graph my parabola. But I do know another point, don't I? Where's my other point?
5, 0.
It's right there. Why am I saying there's another point right there?
Because it's flip-flopped.
Right. It's a reflection of a line of symmetry, right? So now I'm just going to carefully sketch it in. Okay, now I don't know the x-intercepts, but we'll find those later by finding zeros, right? Okay, so now I'm just going to go ahead and sketch it in. Something like this. And there it is. Okay. So you can always get the third point by reflecting one of them over the line of symmetry, right? That's not so bad. Okay, so let's look at your journals and let's see what your journals say, because your journal's got a little